Hi, everyone. Today, I'd like to introduce you to Dr. Lasse Folkersen. He's a leading genetics expert helping turn DNA science into tools we can actually use to live healthier lives. He was previously an assistant professor at the Technical University of Denmark, scientific advisor and lead scientist to companies, a key figure at the Danish National Genome Center, and is currently the chief scientific officer at Nucleus Genomics, a company aiming to make personal DNA insights more accessible. With over 150 papers, 2 patents, and a book titled Understand Your DNA, Dr. Folkersen has spent his career showing you how you can use your genetic code and how you can use it to transform the raw data into real-world health guidance. Welcome, Lasse.
Thank you, Lucas. I'm very happy I could be here.
Glad to have you. Well, let's dive right into it. So can you explain a little bit of what Nucleus is and what the mission of the company is?
Yes, I would be very happy to. You said it yourself already, right? You said that we wanted to make DNA more accessible and make it a tool that anybody can use to empower themselves and improve their health. And that is our mission, and it always have been, and it still is. There's of course a lot to unfold in that, and I think we should go through it. I think high level, it is very baked into what we do, this kind of empowerment ideology that we want people themselves to be able to do things. And the reason we do that is that I feel at least that often genetics tends to be cordoned off or inaccessible or difficult to use for most people out there. And that's not, importantly, not to shoot at clinical genetics departments out there. They do a great job. But because there, for any contact with the healthcare system, there is some access bar. Of course there is. Then it tends to create a situation where I would say that genetics as a tool, as a medical tool, is underutilized. And at the very highest level, that is our mission, to lower the access bar for how to use this information in the broadest sense.
Quite an ambitious goal. I agree. I mean, there's a lot of genetic information out there, and I think the science, the research is a bit slow at times in terms of applying that research into clinical utility or usefulness for individuals. So can you talk a little bit more about, or can you talk a little bit about how Nucleus is different from other direct-to-consumer companies?
Yes, I'd be happy to. I think, as you know, I've seen many of your videos. You know, there's quite a selection of direct-to-consumer companies out there. First of all, we need to get out of the way that the companies such as 23andMe and Ancestry.com and MyHeritage, as the name suggests, I don't consider them health genetics companies. They use an older technology called microarray, which is great for ancestry research and finding long lost relatives, but it's not really serious for medical science. So let's put them a little bit aside. That said, of course, there is also, as you know, other players in the field of health genetics, and probably it's a little bit more fair comparison to talk about them. So I will focus on that. The one thing I think sets us apart in that space is our analytics, our reports, and it's very important to unpack what I exactly mean with that. And it comes down from the very basics of genetic science. As you know, there's you could say kind of different schools of genetics. There's rare variant genetics that concerns all the things that are very severe to get. If you have a variant for something in that category, you almost for sure become sick. Luckily, it's also rare. And then there's this other school of genetics, which is the one that stems from population genetics and the big biobank studies and what is known as genome-wide association studies. And it tends to more gravitates toward things, genetic variants that we all have. They're common. We don't have the same, of course, but they're something that affects us all. And then probably as a consequence of that, evolutionarily speaking, their effect sizes are not so big either. It's a genetic school where like it is not like you will ever find you have this common variant, therefore you get the disease. It's more statistical in nature. It is we have this finding, therefore your risk of, say, diabetes is increased 10%. And I think for the question you asked, what sets us apart is we have been really successful in unifying those two schools of genetics. It's almost like you don't see it in the interface, but behind the scene, it really does take those two key concepts into account.
Hmm. I look forward to talking a little bit more about that when hopefully you can talk about one or two case studies. So who would you say this test is designed for? Who is the ideal consumer avatar?
I've been in this for a while. One thing I've always worked with is giving out these polygenic risk scores. I worked on a website called Impute Me before Nucleus, which was just open sourcing of polygenic risk scores. So through that work, and also now, of course, I've come in contact with many people, and I think the one thing that is always true is they are such a diverse bunch from all walks of life, and a typical common denominator is it's people who wants to know more about something about themselves, typically something about disease, but not always. It can go all the way from pure curiosity of where does my gene come from, stuff like that, but also it's quite large groups that go around and feel they have conditions or syndromes that they may not really understand, and typically also they tend to not have much success with the established healthcare system, and those people are the ones I feel often get very empowered by opening up information. So that's an example of the people I hope to help here.
Could you break it down, maybe based on your experience, how many healthy individuals versus individuals that have some sort of disorder or disease that maybe they're trying to find a etiology or root cause for?
Yes, I can prepare this better and brought it up on the screen because we have actually made some very nice studies on this several years ago, where we basically sent out questionnaires. This is not under Nucleus auspices. This is research from earlier, but I worked with University of British Columbia to quantify this a lot, and I'm just trying to click through my notes here to find, so I can actually answer you very, very precisely in terms of percentages of what people like, and generally, I've had it right here. Generally, when you ask people on why do they seek more information, by far the majority, they state things as generally curious. More than 70% of the people we ask that say that is one of the reasons. And then comes the second biggest one is access to health information. More than half of the people we asked in this survey says that. And then the third most common reason for this is to guide lifestyle changes. And I've seen in some of your other videos that this is something you have worked with as well. And then of course there are other reasons. I can list them downwards, but then they become like it's more rare. Like people rarely say for their children family history or wanted a diagnosis in this particular service. So for me, the high level is often this kind of enabling health information for people.
Fascinating. Thanks for breaking that down. That's interesting research you're doing with the University of British Columbia, I believe, right? Let's go back to the product. Let's go back to Nucleus. So what type of testing does Nucleus currently offer?
Yeah, so we base our technology on what is known as whole genome sequencing. It's what we talked about before with the differences from the older array technologies, and specifically right now we base it on a system called Illumina NovaSeq X, which is really best in class clinical grade sequencing. It is believe you asked me earlier about like specifics on details. It is what is known as 30x coverage. We can go down into more details on that. I will say that high level, the precision and accuracy of it is definitely of the same type that you find in any clinical genetics department out there.
Well, I think maybe we can leave that for the end as we'll see how much more time we have. I think that's important to know, but I think you summed it up by saying that the precision and accuracy is very high and comparable to clinical laboratories. So can we talk a little bit more about the test and then what type of information is provided or what kind of results are provided?
Yeah, yeah. Uh, how should we maybe
Yeah, I can pop my results up.
let's do it let's but let me like so I can talk a little bit about what actually happens when you get the data, because I think that is of interest, but I would totally like to go through your results too, but maybe it's good to give this overview first. And so I said whole genome sequencing is actually it's a fascinating technology, how we can measure so accurately by basically reading short parts of our DNA millions of times and then assembling it all on a reference genome and so-called calling all the variants. But we of course go way beyond that. That is pretty established technology how to do that. And when we get the data of the sequencer, it enters a very extensive analytical pipeline, and the different components of that pipeline, they pretty much adhere to those schools that I talked about before, the common and the rare variant genetic school. So for every data we get in, every person's data we get in, we calculate a large set of polygenic risk scores, of course, and then we also do comprehensive scans of various classes of variants, and we can dive into which exact variants and which exact genes we do. But of course, the goal is always just to be best in class and that be the most comprehensive. And I think one of the challenges then come after that analysis, which you could call the scientific analysis, is how to convey it to people. Because if you just make reports that lists 1,000 things unsorted, unbrowsable, unprioritized, I would say it's often less useful, and that has prompted a lot of our design work, and it goes very close hand in hand with science. And one of the things you will see also when we open your report here is that it by default prioritizes things that are most imminent to you, most relevant, and there's different ways you can quantify that. A typical one will be, what is the risk of various diseases for you? And if you do that, you tend to find that, well, that of course is a big common diseases like cardiovascular diseases and diabetes, because so many people have them, right? But then when you add the genetic component, a lot of that becomes quantified in relation to how common a disease is in the general population. And then I'm actually looking forward to see what results you will have. But we work a lot with this kind of communication where so, for example, let's say breast cancer or diabetes, most people have a 30% lifetime risk for that. But because of your genetics, your lifetime risk will then be some new number that I don't know for you. But this kind of generally quantifies and importantly kind of sets the stage for the relative importance of them. And I think this is really key when you work with whole genome sequencing, because there is so much information. And then, of course, the thing that I hope we don't see in your report, but you do see that for some people, is this whole other layer of rare pathogenic variants, because, well, they are rare. That's kind of implicit, right? Meaning most people don't have them. But if they do, then they should and will take center stage. And this is something we worked a lot with, in that if we find that people have severe variants, BRCA1 mutations often come up. It's an example of a gene that's called BRCA1, and it really increases the risk of breast cancer. So for the unlucky few that have such a variant, then the reporting interface completely changes, and kind of like these common risk report. They get overruled or trumped, if you will, and it all focuses on that, as it should. And I think that's a natural consequence of just having so much information. It becomes really important how you communicate it.
Yeah. When I did the test, I skimmed through the results, and what stands out to me with my genetics background is you focus on those, I guess, rare high impact variants, right? And it clearly shows that, and you discuss those, and then you also have the more common variants that you use to compute the polygenic risk score. So I do want to go down those two rabbit holes a little bit more, but I'm not sure if it would be best maybe to look at my data. But first, I want to ask you, I guess, for polygenic risk scores, when you show the risk, is it absolute risk that you're reporting or relative risk?
We provide both, and I think you asked earlier also what I feel sets us apart is that we have done a lot of work on this absolute risk reporting, and I think it's something that's been thrown around since the dawn of polygenic risk score, is that often it is reported just on what is known as a relative scale. A set score is another word people use for it, or a percentile. It's this kind of idea that now we calculate a score for you for, say, some common disease, diabetes, and maybe we find you're worse off than 99% of everyone else, and that's finding. It is. The problem with it is just it's not immediately very useful, because it really depends on a lot of other factors. So if I were to say you're more high risk for diabetes than 99%, you can go from the report and you don't really actually know what that means for you in terms of the rest of your life and risk. And what I say, different from different diseases. Let's bring in some other, maybe more rare disease. It could be schizophrenia, for example, is a good example of something where there's strong polygenic risk score, but it's very rare. If I tell you are in the 99th percentile for schizophrenia, well, that may be triple your risk, or maybe even more. But that just means it brings the risk that you have lifetime up from, say, 0.3%, which is, that ballpark is the population prevalence, so how many people have it out there. Then you have now found that your risk is 2%, which is a lot higher than everyone else, but it's not high by any stretch of imagination. Compare that to the diabetes that many of us, unfortunately, will get through our lifetime. If you get a one of these 99th percentile or very high set score results, that could double your risk. But now you're talking about real impactful changes, taking you from 20% lifetime risk up to 40, 50, something you really want to look at. And therefore, I think when we talk about polygenic risk scores, it should be the standard of care basically today to report these as both relative risk but also absolute risk, because all research just shows that people, users, patients, they just understand it better, and it is more useful.
Yeah, I mean, it's getting there on the clinical side, right, with cardiovascular disease and cancer as well. I think those are the two paving the way. And I think those are the two first ones that are going to be implemented in terms of polygenic risk scores.
Now you
I
say,
think from,
and I want to say more, because now you say cardiovascular, it's a very good example of what one of the consequences of this is, that if you think about it, once you have gone from relative scoring to absolute scoring, you kind of, as a reporter, as a company like mine, you also take on the responsibility of taking a lot of other sorts of lifestyle factors into account. The great examples really are in cardiovascular disease, but they are true for many of the diseases out there, right? Which is to say, if I say your lifetime risk is 20%, but because of your genetics, it's now 40%. And I don't even ask about your sex, your age, your smoking status, your hypertension level, all these kind of things. Then I have already performed a miscommunication. And of course, you can ask for models to become infinitely better and better and better, but it is one of the key challenges in this absolute risk score communication is that you take on responsibility for making it accurate also from non-genetic factors. So I actually kind of look forward to looking at your report, because I can go through some of these things, and this is also why we ask a lot about some of the non-genetic factors.
Most definitely, yeah. And I think we'll talk a little bit more about, like you said, when I look at my results. But I just want to touch on a couple more things before we do that. So in terms of those rare high impact variants, can you talk a little bit more about which ones you report and how do you interpret and assess them? Which ones
Yeah,
are worth reporting?
totally. So this is kind of like the other half of our by now pretty extensive analytics. The rare variants in our reports, we call them high effect variants, but some people call them pathogenic variants, that you can call many things. What we do specifically is that because we have the whole genome sequencing, we basically will call anything that is changed within a gene, and then our analytics, it will run it through by now a very extensive set of different filters. There are some that are very famous and obvious to do. There's a database called CLIA, which catalogs all the variants that is known to that database by if it's, for example, can label them as pathogenic, likely pathogenic, benign, so on and so forth. But it's important to say that that's not all, and you would miss quite impactful and important things if you just use that. One example I like to give is when you get into the world of what is known as frame shift variants. So that is anything where there's an insertion of nucleotides of arbitrary length in the gene that will break the gene, because the gene is expected to be read by these triplets of nucleotides. And so if somebody not somebody, but you're born with say 4 random nucleotides inserted of the middle of the gene, then the reading frame will be completely destroyed and the gene will not work anymore. And because I said arbitrary amount of inserted nucleotides there, that means the outcome space is basically infinite, right? I mean, it's like, it's all very good that CLIA is getting more and more comprehensive, but if we get a customer with a 7 nucleotide insert of some new arbitrary combination and we only checked for CLIA, then we would not know that. So therefore, we also, of course, check for frame shift variants in genes where those should be checked for. And I think by now there is so many good computational resources to put on and help in that first filtering step, which we of course do. It's very interesting to follow the field, what comes in kind of like further categorizing than just ClinVar. So that's the process for filtering the whole genome. It's important for me to say that at the very last stage, and this is a requirement because we want to be clinical grade and certified under both CLIA and CAP, then we also do have variant curators that look over every single of the pathogenic variants and perform their own review into categorizing it as pathogenic or likely pathogenic. So that's kind of like that's the overview of that process. And then the last bit of detail that you may ask there is, of course, what genes do we do that for? And the answer is depending on when did you ask, because last year when we went live with our first product, it was only, to my recollection, something like 100 or 200 genes. But that's, of course, something we continuously work to expand on. And right now, before this interview, I was very busy putting the final test for our latest expansion, where we now put it up to 2,000 different genes, where we will perform all these evaluation and checks to scan for rare variants. And luckily they are rare, but if you have them, of course, they should be reported.
Okay, very interesting. So you do look at all sorts of variants within those 2,000 genes, and these variant interpreters, these curators, can you talk a little bit more about them? Do they, I imagine they're following the latest clinical variant interpretation guidelines and when they're classifying variants?
Yes, indeed.
Okay.
It's ACMG criteria that is the final call on that. And we can talk more about what that exactly is, but in a word, it's all the things that I said already, like the is it a frame shift? Does it segregate in family? These kind of things. Is it rare? That's also a criteria. We don't want to report out something that's super common.
And is this oversought by some clinical scientists or clinical molecular scientists?
Yes, we have a director that signs off on all of it.
I'd love to talk more after this about your efficiencies. A lot of clinical labs struggle with efficiencies. I mean, it's a bit of a tangent, but we struggle with the amount of data coming from targeted panels, and we're starting to look at whole genome and exomes. And obviously, there's a lot of variants that need to be assessed, and it takes a lot of time. Maybe at another time we can talk about your
So,
hypothesis and secrets to efficiencies. Okay, so maybe now, actually, a couple more things. Okay, we talked about those rare monogenic variants. We talked about polygenic risk scores. You also do carrier screening as well, right?
yeah.
Maybe can you just touch on that for a second, please?
Yes, we should do that because that's good to remind me because the thing is then that I said like if you have this variant that is of immediate impact to your health, of course, like on kind of overrules the entire your health reporting interface. And I named the example of a BRCA variant, which for this purpose is kind of not a very good example because it has dominant inheritance. So if you have one copy, that's enough. It will impact your health. Also, the next generation. So in that sense, you could see it as a carrier. But the reason it's a bad example was this dominant inheritance. We of course also scanned for many of these 2,000 genes. I think more than half, quite a bit more than half, they have what is known as recessive inheritance, when you know that, but you need two pathogenic copies, one in each of your chromosome, one from mom, one from dad, to be effectful. And if you don't have two, then you are known, then you are what is known as a carrier. And it, ideally or theoretically, I would say, then it doesn't have any impact on your health. The modern science, I think, have shown that sometimes it may actually bleed a little bit through and have some semi-additive effects. But let's pretend that that's not the case here. What happens then is that for the genes that we have checked for all these things, all these genes, of course, there will be many where, okay, this person did not have two variants of in a gene that has recessive inheritance, so it won't overrule or affect that person's own health report. But in our reporting section, there's a whole other section called family, which is intended, of course, more for the next generation of people, the kids. And in that, it will list all the cases where you had, for example, one variant in a gene, but it won't impact you directly. And then it can run through the calculations with a current or future spouse to quantify the risk. And then it becomes really classic Mendelian risk categorization here, right? I mean, the whole if mom and dad are both carriers and they get kids, and then we have these, we can go and look at them in your report later, but if they have 4 kids, then one would be affected, 2 would be carriers too, and 1 would not at all be a carrier on average, of course. But we launched that last December, and I think one of the things that really struck me is that that had a lot of demand. Like people really like to see that, and I get it actually because it's like it doesn't affect a person themselves, but many of our customers are also quite young and maybe they're planning to start a family, and then it becomes super important, right? Like it's like if I see I'm a carrier for something, and I know personally I'm a carrier for I think it's 3 different recessive variants, but I only have 1 copy. Immediately I would want to know, does my spouse have the same? And then that's the beauty of it, right? You can check, and in most cases, the spouse does not. But if they do, that opens a whole other chapter. So that's a little bit high level about the carrier screening here.
Yeah, and I've noticed that too. There's more and more demand for carrier screening, and there's even been. I'm not sure if there's been a dating service created based on that, but I've heard rumors about it. So, where you can screen for a potential partner based on their genetics or what they've carried.
There is on various levels of seriousness. Now, I do know some DNA dating sites. I don't think. I think the serious players like us, it is more established couples. And I think it's important to say there that if you then come in the situation that your significant other actually is a carrier for the same you have, it's maybe a little bit too fast or tongue in cheek to say, hey, then you should split up, you're not a match. Because today you can actually do something, you can do a lot of stuff. We can open that up later. And for me, the most important is just the knowledge. If you know you can do stuff, if you don't know, then it's just random chance.
I agree. Genetic power. I mean, genetics knowledge is its power, right? And you can actually do something about it in many cases. So then beyond health, you associate these variants also with wellness and with certain traits, right?
That's correct. We do again. It's also popular demand, and people kind of expect that. But we calculate so many polygenic risk scores, so why not also do traits? We have a trait section with typically sought after metrics such as height and BMI and forgot them all. Muscle strength, extroversion, IQ is also there. That used to be controversial. I don't really think it is anymore. For me, I think I like to have them there because they are very illustrative. They're very they're educational in a sense, because of all the traits that I just mentioned, we pretty much touch on the entire spectrum of genetics and how predictive stuff is, all the way from height, which we do really well. And I don't necessarily just mean nucleus. I mean, we do, but height is just very heritable and the scores are very good for it. And then all the way down, you could say, to things that are, well, the scores are not very predictive and they never will be, because it's not a very heritable trait. And by that, I mean all these socioeconomic traits and psychological trait, openness, adventureness, all this. They are, it often gets said that, are they unserious then? And I think no, but you can communicate them in unserious ways. I think the key is just to be able to say, we can calculate this score for you, and it says very little. The error bars are incredibly wide. And I think that's good genetics. That's good genetics communication, rather than just pretending that, oh, we cannot calculate something at all. And because then, people are just going to want to know anyway. So for me, the traits section is very much there as an educational layer to this, and people like to use it as such.
Mhm. Yeah. And then I want to touch on, I don't believe you currently report on pharmacogenomics, right?
Not currently. Not currently. It's yeah. Why don't we? We have algorithms running and pilot test and all stuff, but it's not currently live. We're working on it, because
Or yeah.
the reason I'm still happy you asked, because I want to say that it's like it's one of those fields where I think it really has impact. We talked about many things now. If you find your carrier for a severe variant, that will have an impact for you. It is also interesting to know your polygenic risk score for diabetes, and you can change your lifestyle. Of course, you can. As for impact, pharmacogenetics is special, right? Because it has this, like, you can actually make active choices right there. I think the key challenge for pharmacogenetics to really break through is not to solve the calculation problem, because in my mind, honestly, that is pretty much solved already. We can make long reports of pharmacogenetic risk scores and find long list of drugs people should take more or less of if they ever need them, or maybe avoid altogether. The real problem in pharmacogenetics is this immediate need, like connecting the information to the place where the information is needed, because it helps nothing whatsoever if you sit 40 years old and read a report about your statin choice preference or something like that, because you hopefully don't need it at that age. But then 20 years later, maybe you have high blood pressure, you will have forgotten that. But that's the place of diagnosis and prescription is where the information should go in. And I think there's a lot of cool research. We have not really, I don't think anybody have really a good answer to this, but we definitely want to provide the information, of course, when it is ready.
So it sounds like it's coming down the pipeline.
Yeah.
Fascinating. Can we get a little bit more nitty-gritty about the technical details of your whole genome sequencing test? Do you report on structural variants, copy number variants, and then deep intronic variants?
That was long. So let's start with the CNVs, the copy number variants, and the structural variants. The answer is yes, we do, but there's a but.
Sorry, can I just pause? Could you explain that for the audience as well? Because I'm sure a lot of people on
Yeah,
will.
so the question here is about what is known as copy number variance, which is a case of structural variance. And why do we call it that? Because we've already talked about single nucleotide variants, and we also touched a little bit on frame shifts variants, where I gave the example of if something has 7 nucleotides inserted, it will the gene. There's no, you could say that's a structural variant. It's just we don't, because structural variant tends to be a reserved word for much larger reorganizations of the genome. People can discuss forever exactly where the line goes, how much larger, but we are talking about several kilobases, like thousands of nucleotides at least, if not much more than that. And if it's a copy number variation, it just means that, well, I mean, now there's maybe a duplication of one large region in the genome. It's twice in your genome, or it's deleted, stuff like that. Structural variants, they would then be considered copy number neutral, right? And I think, why do we divide them up like that? Well, they're longer. That's one, but it's also technology, and that's a key point, that since we do this, and I do think it is state of the art Illumina sequencing, it's a little bit difficult to precisely estimate them. It's not impossible. We do, if you are a Nucleus customer, you can go to the download section and you can download your CNV files and the structural variant file too. They come in a rather technical format called VCF files, and the data is in there. But maybe the reason we're a little bit hesitant to automate it and put it into the main reporting interfaces is that the precisions are just not as good. Like I quoted before the 99.9% precision and recall for the short variants. And that's true for all these short variants. They're really easy and high fidelity to call, but not the longer variants. The studies I tend to follow, we're more at 30, 40, 50% accuracy, and it's just it kind of makes it a little bit more of a oddity that is hard to consistently and systematically put in an automated interface. Now, of course, it is people's DNA themselves, so they can download it. And I think the typical use case is for many people where they know a certain copy number variant segregates in the family, then that information, of course, is available and can be aligned. But the concept of, I mean, basically we do population screening, right? That just becomes a little bit more difficult. So,
and the second part was the deep intronic variants. So
yes, so
yeah.
the deep intronic variants, you ask good questions. We do, as I said, we filter for many types of variants, CLIA and so on. So the easy answer is if it's in CLIA, it will be found, but there's more to it, right? We do have filters in place that will check also for variants adjacent to the exon, because they may affect splicing. We don't really have an automated system for deep intronic variants, I'm afraid. It, of course, is something we will work more on. There is a fairly long list of increasingly more esoteric concepts in genetics that needs to be handled. And if you want to add something to a list of CNVs, structural variants, deep intronic variants, I will say also that something such as repeat expansions and also some of these very, very complex pseudogenes such as SMN1 and 2, they are also of the same concept, where it's kind of like I can happily say we report 1,000 genes, and that is correct, and it is true, and it's high fidelity, because there are 1,000 easy genes. We're just looking for frame shifts or stop codons and stuff like that. But when it becomes repeat expansions and duplications of genes like SMN1, it takes a lot of care. We are getting there. We will very soon launch our repeat expansion detection system. The others, SMN1, takes a little bit more. I don't want to overpromise when that gets launched, but it is definitely on our radar.
With the current technology, or are you transitioning to more advanced technology, what's called long read?
That's a good point, right? I mean, it's like I think that's a key part of what is holding back. Like, it's always this kind of like decision of what is ready for short read and where is it probably better to just not report on it and say so because like the technology is not ready for it. I think for many of the concepts we are discussing here, that could actually be the problems. Or more like the reason. Don't even pretend we report on it in a useful way because it's better to wait for long read sequencing to come. It is here soon, not right now.
That's fair enough. Can we break down a little bit reanalysis? Do you perform reanalysis of the results as new data emerges?
Yes, very much. It's interesting how in Nucleus we're such a engineering heavy company. So sometimes I feel I even have to explain internally that reanalysis is not always done because it's such a, of course, situation for many of our engineers here. And the answer very much is yes. Every single sample that we have ever received, whenever we update the pipeline significantly, for example, these expansions of gene list, well, then we run all the samples again, and there are people that will get new results. And I think our communication department they have worked a lot with this because it's a difficult message, right? I mean, you saw your genetic report, we said everything was okay, now we have done something new, and now we have actually found something. I think many people react a little bit that's odd, or why didn't you find that up front? But I mean, since you ask, it is good to discuss this, right? Because I think that's just the state of genetics. We continuously learn more stuff. We get better technologies. We get better bioinformatics, and so this will happen. And will happen both for rare variants, and will also happen for polygenic risk scores, and it will also happen for all the more exotic concepts we talked about.
Okay, I want to go back to a little bit. You mentioned that you perform these tests in a CLIA certified lab. I think it's important to note, I believe the lab is in the United States, right? You don't outsource this to another country?
Everything is US based and sourced. And
I think that's important to note for the audience. Have you benchmarked your pipeline against other labs, clinical or not?
Define pipeline, I want to say, but the answer, of course, is yes. But when I say pipeline, the Nucleus pipeline, it is the entirety of it, and it's of course super modular. So on a module by module basis, yes, we have. To give an example, I said we have the raw sequencing data and this alignment procedure that is done to actually identify where there is variance, short variance in this case, and our philosophy is to just basically use the components that are the best, use their benchmark, but also, of course, perform our own. Currently, we do the alignment with the Illumina Dragon caller, which I do believe is best in class. Also in there was this NIH difficult to call competition, and the Dragon caller came out really on top. So that's one example of something that is well benchmarked. Then I would say, you can pretty much go through component by component and ask, and the answer is always yes, but there are things that are more established in their way of benchmarking. Raw variant calling is one that I feel is very well developed now, whereas in other fields, for example, Polygenic Risk Score is actually a good example where I feel I think the science field as a general, we've not done as good a job at coming to terms with having standards and gold standards and unified comparison benchmarks. And I think that's something we will see happen in the next years. And it's not to say that everything is useless. It's just it has come farther in the more established clinical space, such as with short variants. So generally, to your question, yes, we of course benchmark everything, but the degree of benchmark kind of goes with the scientific concept in question.
Yeah. And then going back to those single variants that you find in that are high impact, do you confirm them with any methods, secondary methods?
Um, in the benchmarking stage, yes, we have made the decision now that operationally, we also want to keep the cost low, right? We do not do, for example, Sanger sequencing. I know that was earlier. I think in the earlier days of whole genome sequencing, that was very commonly done high standard. When you find a rare variant, you Sanger sequencing it. I gotta say that's my opinion is that it is a little bit redundant to do so now. The short variant calling is of very high quality. I know out there's a lot of different opinions on this, and there are also some states that regulate this quite a bit more. Uh, so what we do is more. The answer is no. We don't like if you have a rare variant. I hope you don't, but it will not have been Sanger sequenced. Instead, the methods that we draw of it is just QC and validation and positive controls that we continuously maintain and make sure that we do find rare variants as we should, and we do not find false positives.
I think that's fair enough because I would say most clinical labs are moving towards that too, not to confirm these variants that they find on the diagnostic side. So a couple more topics I want to tackle before we get into my results. So I think one big one is the topic of privacy security. So a few questions in this area. Who ultimately owns the results or this genetic data when somebody gets sequenced by Nucleus?
Well, it's the customer paid for it. It's their data, right? It is completely okay for a person to buy a Nucleus product, download their data, and ask to have it deleted under all the regulations that follows with CLIA and CAP. So ultimately, the customer, of course, right? I will say that it's for most people out there that's not a very use of the data because very few people readily can analyze a VCF file for themselves. So by far the majority of people they do choose to leave the data with us. Also because what we talked about that there is continuously updated analytics and reruns of our newest version of the pipeline.
Great to hear. And what data security safeguards do you have in place to prevent, situations that happened, with 23andMe where there were breaches of patient information and data?
Well, yeah, it was not very good for the field what happened with 23andMe. We are better than that. I kind of wish I had our head of engineering here. He's very good at explaining that, but they drive a hard hand on security. What we do right now is we adhere to something called the SOC 2 standard, SOC 2, which is this self-reported but rather severe standard for security. Now, I'm not a software engineer, so I couldn't really explain what, but it involves a lot of two-factor authentication and extra safeguards and demands for continuously upgrading everything so there's no vulnerabilities. I would prefer not to really overstate what I know here because it is the responsibility of our engineering department, and I think they're doing a great job with it.
That's fair enough. And then I think the other topic I wanted to tackle here was, do you share the data with third parties? And if you do you anonymize the data, and how does that work?
So you ask if we do, and the answer there is no, because we are just getting started, so we have not yet. So that's very easy. That's not a future-facing statement, of course. We do intend to also use the data for what I see is a good thing. Like I think data mining for purposes of improving algorithms, improving genetics, improving drug discovery, they're very good. They are ethically beneficial, if you will. The, ultimately it's up to the user. I mean, we ask for if people want to participate in research, and if they say no, well then they don't, and if they say yes, and most people do, then we will do this. You had some question about anonymizing. I can't answer actually right now because we've not done it yet, but of course we will adhere to all policies that exist in the area, and the consent form you use for signing up for this. It is very, very detailed and very clear. So I really recommend people to read it. And further, I actually also want to say also that I recommend people to sign up for Sharing for Research. It is all the cool things we do, all the things that genetics can do. We can only do that because people are willing to participate in research. So I do very much see it as a greater good that people should consider. Up to themselves, of course.
I agree. Okay, so last topic I want to cover is patient results and patient experience. So we know that genetic results can be overwhelming for the vast majority of people. So how does the company minimize the risk for misinterpretation of data?
Yeah, it's it's a challenge we all have in genetics, right? And we did talk a little bit about it before. This kind of like relevancy sorting. I think that's incredibly important. I think many problems that are created with this kind of misunderstanding and non-beneficial effects in the patient side, they ultimately stem from customer interface experience being bad, and I mean that in the broadest sense. Like, I think it is incredibly important to create our reporting interfaces such that they automatically highlight what is relevant to people, and if there's nothing like that, then also state that, so we don't kind of cause concern or anything like that. Additionally, it is important to talk about the genetic counseling component. We do have that. We have tried to bake it as much as possible into the product. We have even sometimes discussed this, if it should be mandatory or a fixed part of it. But ultimately, that also becomes a problem. Not that I don't like genetic counseling. I think that's a great opportunity, and I recommend people to take genetic counseling. But we just have to accept that there are many people that don't want to have that and pay that extra cost, and I feel it's important to respect them also. So currently we have split up the cost in the sequencing, automated analysis, and human variant curation, with the opportunity to speak to a genetic counselor on top. Now, if anyone ever does have concerns or find things that concern them like that, of course, like very much, I recommend them to use that opportunity. And it's also something we try to bake into the interface, so that, like, if you have a high polygenic risk score for diabetes, but your risk went from 20% to 30, it's not going to be red buttons and genetic counseling. But if you have a BRCA variant, interface will very much, like, almost force your hand to click that booking of the genetic counselor, because we do think that is the right thing to do.
Mm-hmm. So you said genetic counseling is available at additional cost. Is this post results, or do you also recommend it for before getting genetic testing?
I know that's a big discussion, right? Many genetic counselor feels it should be upfront, and I'm very sympathetic to that viewpoint. I just have to balance it with many people that don't, like many ordinary people out there that don't see it like that. They don't understand why they have to pay extra for a service which is not the one they wanted to buy it. So we have not done this mandatory genetic counseling, but we tried to make it as easy and smooth and seamless, and also cheap, by the way, to have that as an add-on. particularly in the cases where it's relevant. I think that's also an important point to discuss here, right? Because genetic counseling is good, but we can't have a system where every single one in an entire population have genetic counseling, mostly because many people will not need it. It should be prioritized for the people who need it, typically the ones that have pathogenic variants.
So is it an option to get pre-testing counseling through the Nucleus
No,
portal, or is that something that would have to be done
we
through a
don't.
different party?
No, we don't actually have that. I mean, it's not difficult for people to just hit the genetic counseling button as the first thing before they look the report. So that's doable. But
Yeah,
again,
I know it's debate in the field, and
it is, and I'm very sympathetic to genetic counseling, but I gotta say it's balanced with what not we as a company want, but what people out there want. Many people, they just want to see the results. They really do.
yeah, I believe that. Yeah, I've seen it too, to some extent. Okay, so a couple more questions. So first one was in terms of the results. Are these, is this data or this test recognized by any clinicians or genetic counselors or any laboratories that you work with or affiliate with?
It should be. It's CLIA and CAP certified, so it is clinical grade. That said, I mean, we get plenty of signal of, how to say this in a nice way, some suspicion. Like we really try to work very hard in getting into the box of clinically accepted. But I think, and that's just true in any system in the world, not only in America, that if you work in a hospital system, of course you trust your own test more. I don't think there's a good catch-all answer to why or if anything can be done about it. I think it's an everlasting, ever-going challenge. I do think that I will say that we have a lot of customers that have found stuff of interest, went on to get further screening with their own medical system, their doctor, even been escalated further into the medical system. And I think that's a good thing. And if you could say the price of it is that sometimes some doctor will say we should measure this again, that is fine. Like, I mean, that like if it really is consequential, then I don't see the problem in measuring things several times. There are also cases where doctors will look at our reports, particularly the physician-facing PDF is a clinical grade report, and then take actions depending on that. But that really is up to them. That we don't take on that liability.
Great. So then could you maybe talk about one or two case examples or individuals that have taken the test and have improved their health based on the results?
Well, that's a good question. I mean, I know many of them, but also I'm not at liberty to just share people's stories. So I'm really digging here. It's probably most safe to talk about because some of our customers, they go straight to Twitter and then they blast out their own results. So I can only assume that's implied consent for discussing it. We did have one guy who managed to get like a semi-viral tweet or almost, because he found that he was he had a fairly severe form of hemochromatosis, and hemochromatosis, to be clear, is some of the variants that do that. They're not so severe. It's limited penetrance indeed, and our reports reflect that. But this guy, he actually had a more severe form, and maybe you also know this, but hemochromatosis is one of these diseases that are like really annoying to diagnose, because the symptoms are just fatigue and general malaise, and that's hard to find. But then he took the test, and of course, like, it's not like I took the test, everything's done. He went to his own doctor. He got a, I believe it's a blood test for iron levels, and then it was pretty clear, okay, that probably is the problem. And it's nice because it's actionable. He can change his diet and do something about it. And also, he was a very extroverted person, so he promptly put it on Twitter. And so I think that's completely fair to discuss. Unfortunately, they have like thousands stories like that, but I don't think I should share them in an interview like this.
Yeah, you definitely want to breach patient or individual confidentiality. I'm sure individuals found high impact variants in BRCA and so on taking your test. But in terms of polygenic risk scores, can you maybe talk a little bit about in examples or one example where individual, had a high risk for a certain condition based on their polygenic risk score and, they changed their lifestyle? You don't have to talk specifically, but in general, have you seen that trend? Because there's also debate about how the utility of these results and do they actually have an impact for individuals? And, that could be a topic we could talk about for hours, but uh, have you seen individuals be motivated by these results and actually make actionable changes?
Yeah, it's a good question, right? I mean, many people, especially in the PIS field, have been asking this, like, okay, we do all these measurements and we empower people, and that's good, but could we also just give out a flyer to everyone about improving your lifestyle and eating healthy? That's a little bit like the question. I don't want to be too anecdotal in the answer, but because I don't know of anybody who went to Twitter and went viral about it. So patient confidentiality, but also at the end of the day, it is going to be anecdotal. Yes, of course, I know people who found out they were at a high risk for diabetes, and then they were like, okay, actually, maybe I really, really should do something about my my diet. I feel it often goes with family history. I think some of the best and most useful, actionable stories, if you will, are the ones where several people in a family test, and especially siblings. I mean, because siblings have a whole distribution of scores, and maybe they have diabetes was in their family. They typically will know that, and then they will all get. Well, that's not a guarantee, but we have seen many cases where they then, of course, all get high diabetes polygenic risk scores, and it's typically the sibling with the highest that will adhere the most to it because they can see their grandmother or their aunt or whatever who had diabetes. So I think that's more of an opinion than a scientific statement. Is that yes, we can't just give out flyers telling people to live more healthy and exercise and eat healthy. Fine. But there is a personal aspect of it that is hard to quantify, but very, very real. I believe that. But it's an opinion. It's not a scientific statement.
Yeah, I'm of this similar opinion. I think a blanket statement such, exercise more, eat better. I think we're beyond that now, right? The science is showing, depending what your risk is, if your risk is high for diabetes, for instance, I think in general, and it's not applicable with everybody, but in general, maybe a lower carb diet would be a better idea for that individual versus
Yeah,
somebody that's a higher risk for cardiovascular disease. Diet lower in saturated fat would be better for those individuals. And you
exactly.
could say, why don't you adopt, the ideal Mediterranean, low carb, low saturated fat diet? But people want to live their lives too, right? So maybe it's easier for some individuals to tackle certain aspects if they know, okay, I'm at high risk for this condition versus other conditions, then it's easier to navigate that versus I'm going to lower my risk for all the conditions by having the ideal diet, ideal exercise regime, and so on.
Hmm.
So, I
That's
mean, that's my opinion too, and it's a general train of thought. But yeah, I think we can get more specific with exercise too, with sleep, based on what you're at risk for. That information is coming out right now. Okay, so maybe I'll bring over my results and we can talk about them. You can lead me through them,
yeah.
and then we can wrap it up if you still have time.
Let's do it. Let's do it.
Okay, you see my
Oh,
screen?
yeah. I can see you don't have any red bars. I'm very happy.
I was happy to see that too. Yeah.
Yeah.
So maybe
And
you can take everybody through this, please.
this report would have looked very different if you had a BRCA variant or something like that. Just like this is what we talked a lot about. So I'm happy you didn't, but that's
Thank
kind of
you.
the
Me too.
where to go then? Like, it's going to be a little bit like repetitive of what we talked about theoretically, but I think it's a good idea. So I think if you could click the tree there in the middle where it says elevated, then you get. Well, I mean, as you can see here, it is an overview of a lot. I mean, you can scroll down. There's like 2,000 lines. So right now, I think for US there would be 1,000, but soon 2,000 lines because we continuously expand. But the key then is like prioritization, and course, you could say, hypertension is on top. It wouldn't be for everyone. Maybe somebody has a high diabetes risk, then that would be on top. But it's for somebody who doesn't have a high effect variant, a pathogenic variant. This is a very common view, and the thing I said with, for example, BRCA variant, if you had that, then breast cancer would be on top. Or if you had some super esoteric long QT disease, then that report would be on top. Can you try to scroll down like just by a lot, like several pages down? Just let's have a look at it. Go faster. That's a lot. Now it becomes now we start getting into these kind of like, they're very rare diseases, and we want to list them all because we check for them. The risk, we can't say it's none because genetic is not that deterministic. Or you can stop scrolling now. But the point is that these exist and they're very important in genetic reporting if they're positive. That's the key, right? So luckily they're not for you, but if, and for many others they will be, then whatever report it is that is positive will be lifted out, and that's where a lot of the actionability comes in. Can you click hypertension on the top of the list, just to give an example here? And then scroll down a little bit. Well, first it says this thing that there are actually there are syndromic forms with pathogenic variants, but you do not have any. So if you had, the report would look very differently. But if you scroll down to just one page or so, that one, I wanted to talk a little bit about that because I think it is some of the things that I'm personally very proud of, and the science is backed up very well, and it's just what I consider good reporting in genetics. It is this idea that we should strive to give out absolute risk scores, and we should strive to give out absolute risk scores in connection with the general risk, because it is something that can be well understood by many, and it also carries a lot of information for the experts if they so want. So we can try to take that apart a little bit. You can see that the right plot here is just as a typical male between the ages of 40 and 59. So hypertension is very common, right? So many people have that, but you, on the other hand, because of your genetics, so that's the left plot, you have a much lower risk. So that's good for you, and I think that's communication that works both at the good for me. I have low risk, like take it away and don't make it more complicated. I like that. But there are details in this that we talked about before that I think are important, because if you go to your schizophrenia report, you can, if you click back, but it's not important that you try to find it while we talk. If we kind of memorize it, have that in our mind, the idea of a very common disease, and then a very rare disease. Okay, Alzheimer's, I don't know. Take the schizophrenia there, and then down to the same plot. This really illustrates this thing that you are at, well, you have twice the risk of schizophrenia than the population. And if you were in some bad reporting interface, or just say, you have twice the risk of schizophrenia, you'll go home and say, oh no, that's horrible. Twice is bad. It's even more than twice. But here you can see that, yes, and then you are from a very low number to a slightly higher number, it probably won't affect you. And we're doing that for the common diseases now, but we try to bake that more and more into the reporting interface. And ideally, in some future, I would like this to be true for all types of genetic variants, also the rare ones, also the repeat expansions, everything that can be quantified. And I wanted to also take in as many possible quantifiable of the non-genetic factors. This one, for example, is only age, because there is not so many other things for schizophrenia. But in your cardiovascular report, for example, it would also take in information for all the things about cholesterol, hypertension, if you had answered those in the survey, and if you had them, then it would take that into account. So that's generally the reporting interface, and looks good, I would say, for you, in the sense that you don't have a rare pathogenic variant. But let's go to a section called family. Unless you have questions there, we can stop there. But I think we should look at the family there. Yeah, exactly. Because you also asked about that earlier, so we can go through that. So, okay, you actually carry for two things. I'm myself. I'm carrying for three things. I even forgot what they're called, but this is the kind of information that now I don't know if you want more kids or anything like that, but for a person who is in the process of starting a family, this is really important information. This is why we call it family, right? Because even though, what does it say? Combined oxidative phosphorylation deficiency 1 is not something you should be afraid of. I can't say you have zero risk, but you shouldn't be afraid of it just because you're a carrier personally. Then if we imagine that you are now planning to have a family with your spouse, then it is incredibly important to know if that spouse is also carrier for the same. Try to click it, that combined oxidative phosphorylation deficiency 1, and then scroll down, and you can see we worked out all the, I mean, it's not rocket science, but we have worked out all the Mendelian segregations. Given, you can see right now it's highlighted, it says if your partner is a carrier. Mm. Well, it's good old Gregor Mendel here. Then a quarter of your kids will be high risk for that disease, and the remaining will not have the disease. And since we're experts, you can click the show carrier risk. Then it further makes the calculation. It's a little bit up to the right there, up, and then
Is clear?
yeah, try to click that.
We'll share your risk. Sorry.
This one, yeah, that makes it. It just makes it slightly more involved. We can look at that where it does half with the carriers. I do say that you know how complicated it can get once it gets into sex chromosomes, and the interface gracefully handle that too, taking your sex into account and your spouse. And then, of course, the real beauty of it is that then you can partner up with a spouse. And you can link your results, and then he will not have that if your partner is carrier, if your partner is not carrier. It will actually do the calculation. Luckily for most young couples, they are not both carriers of the same. But if they are, you get out that information, and you better believe there is a very big button with genetic counseling too. And then we do get into some of the things where it's really a case of information is power, because two young people that want to have a family, they're both carriers for this. They're rolling a dice, and 25% of the kids will have a horrible disease. And in a non-carrier screening setting, which is until now every single pregnancy in human history, that just happens, and a ton of resources are put into treating that child well, and they should be, but it's complicated because the child is born with a very severe disease, typically, depending on the disease, of course, but most are. And then comes the thing like where information really is power for the couples where they are both carriers. You can do stuff, and the field of in vitro fertilization and screening has come so far, and it is very central to where we as a company are moving towards now. Is that for all the people that, I mean, again, most people get a blank slate and it's fine, go. But we want to be there for the couples that then have where they both are carrier, and you can perform, for example, what is known as PGTM, which is then you take out the embryos in an in vitro fertilization situation, and you can actually scan the genetics of the embryo, which is not the embryo itself, it's what's known as the trophoderm, like some adjacent cells, but you can scan them, and you can figure out that if you took out 10 viable embryos and they look good, then instead of rolling that dice and going into a quarter will be at higher risk, then you just choose the remaining 3 quarters, and there you have, in a much more humane and efficient and medically sound way, prevented a very horrible disease that may or may not be treatable, but now you don't need to treat it. And for me, that is just preventive medicine in a nutshell, and I'm very proud that so many people use this, and I think they should. And if I ever wanted to have more kids, I don't, but if I did, then I would definitely do that today as well.
Yeah, I mean, I've already had my kids as well, so yeah, this kind of information would have been very useful. Knock on wood, both my children are healthy, so but it would have been nice to know before. I'm the type that I like to know things in advance. And like you said, I think you really hit the nail on the head that there are things that can be done now, right? You don't have to roll the genetic dice. If you know that you're a carrier and your partner is a carrier, there are things you can do with the technologies here already, right? The PGT.
Mm.
Okay. So counseling button, I think we should maybe mention here too, if somebody's interested in counseling for the results, especially if they have those rare high impact variants, they can add that on. And then maybe take a quick look at traits as well. These are some of the traits that we talked about previously.
Yeah, we can take a look. Again, my main point here is that, like, I think for me, it's illustrative how the scale of predictiveness from some things we can do really, really well. I actually don't know how tall you are. Were we right?
Yeah,
Five.
no, it's pretty accurate. Yeah.
Yeah, that's one I'm proud of. Like, it's not about proud of being good. Like, it's just a state of genetics. Some things are both heritable and well characterized. Other things are heritable but not so well characterized, and yet other things are just not very heritable. And for us, it's all about. Actually, can you click the height? Then we can look at the screen there. Um, there. So we and always developing our interfaces, but what we try to say here is this kind of like 100 people, like 100 typical males would have the extent of height that is the lower uh, blob there. But then, well, it maybe should have been a bell curve, but it's basically the confidence interval and the point estimate for you specifically. And then as technology grows better, those blobs will become more and more narrow up until the point of heritability. And what is the heritability? Well, that depends on the trait. Height is very heritable. I think adventureness will always be incredibly wide error bars on this, and it even is today, but it will never become very predictive. And I think for me, the reason for having traits, I know it's a little bit gimmicky, right? But it's like, it is that educational aspect of it, because all the learnings you have from this, they are very true for diseases too. We have scores for depression, and many people say, why do you do that? It's not very heritable. That's true. And we try to explain that to people using the best we can in communication, that yes, depression have a population prevalence, and your scores imply that you almost don't change away from that population prevalence, i.e. it's not very heritable. But we don't want ever to say, like, you can't have the information, because we know very well then people just go and go out to some dubious third-party site and, and try to calculate it themselves. And then on the other hand, like height, we do have scores that are becoming very, very predictive indeed, particularly the big common complex things like cardiovascular disease and breast cancer and diabetes, and what have you. Are currently at a state where there are some error bars, you could say, but they will continue to narrow down, especially as we also take in more and more non-genetic factors. So in that sense, that's why I think we have traits here.
I must say though, your IQ calculations are completely off. This must be an error.
Click it. Click. No, click it. You should click it. No, it's like, look at this UI. But I think
I'm just teasing. I'm not pompous like that. I think I'm not. Yeah, it doesn't matter.
But the one thing I want to note here, because I know there's a lot of people going to listen to this and have opinions about IQ. The thing that matters for me, communication-wise, is here. Look at how wide the error bars are. IQ, like, you could be anywhere in that blue blob, and it's still a true result, which is just another way of saying that our current IQ scores, it's not nothing. It really isn't. There is some component of genetics to IQ, and I will never say that there is not, but it's also not everything. And that seems to just be a very, very difficult message to get out there. but it is so.
Okay, well, thanks for going over my results with me. We have a few minutes left, so I just have two last questions for you. I guess I want to touch a little bit more about the future of Nucleus. Where do you plan on going? You kind of mentioned a few things. You're looking at pharmacogenomic testing. You're really pushing into this carrier testing and in vitro fertilization space. Can you just talk a little bit more about that
Yeah,
or other areas that you're heading?
yeah, that's a pretty good list of what we do. I will say also, like, of things we will announce soon is we are always updating our polygenic risk scores, and we're about to we have really had some breakthroughs on making them better. But that will come. The IVF question you said, like the in vitro fertilization, that's definitely a way we are pivoting, and just to explain to everyone, it is like it just seems so the natural next step, right? I mean, we wanted to be the best in class genetics company with the most comprehensive unifying interface, and then we see how people use it, and they use it for good. I believe that, but very often you get these users, customers who find, oh, okay, I was a carrier for that, and then their spouse also was, and it's like it felt like uh, both we and the customers were very much left with this kind of like, that seems so actionable. Why is there no service for that? And so a lot of our efforts over the last half year have been, you could call it a little bit of a pivot. We still do broad adult genetic testing as well, of course, to get to here. But it just seems very much to me that this is the place to go, not only from a business but perspective. Sure, like there's many people who wants to pay for this, but of course they do because they have utility, right? I mean, it's like it's such an obvious thing to do to carrier screen couples and take action, and in this case, action almost always means some variation of PTTM and IVF. So you will hear more announcements from us in the future on that. We already have it. We want to go further, and as I said from the beginning, our philosophy, which sometimes rides a little bit up with people, is that ultimately it is just people's own DNA, and therefore it does tend to have all the information available, so that even though I care the most about preventing disease in the next generation, I will say that there will never be anything where like, oh, this is too controversial to say anything like that, because really I think that's just an affront to the people themselves. Why can they not get something they want to know from their DNA? So we will get more into that with better technologies for IVF and better reporting, and basically more enabling of people from that in genetics.
Yeah, I think, direct to consumer companies have come a long way since, the days of 23andMe when they started. And I think Nucleus is setting a new standard for the way direct to consumer testing should be done. So, Lasse, it's been a pleasure. Thank you for your time. And my final question is, where can people find out more about Nucleus and follow you or your research as well?
Our website, www.mynucleus.com. I'm pretty sure you can just Google us. I think we are we are pretty findable now. Thank you for your time as well. It was a pleasure.
Thank you.